Let's take a look at Gaussian Jordan Elimination on HP Prime Graphing Calculator. And let's take a look at this problem here. We got x plus y minus 2z is equal to 3. And 4x minus 2y plus z is equal to 9. 5x minus y plus 3z is equal to 16. And double check all my signs. Okay. Well, let's write down the matrix that goes along with this. We're going to drop our x's, y's, z's, and equals and keep the numbers in their signs. So I got 1, 1, negative 2, 3, 4, negative 2, 1, 9, 5, negative 1, 3, and 16. Now let's go ahead and put this into our calculator. I'm under my apps menu here. You can press apps if you're not already here. We won't go into function. So I'll highlight function, press enter. And then I want to click my home button. Go right here. Okay, we want to input our matrix in first. So I'm going to do shift 4. Now you may or may not have something here on M1. I'm going to press delete to clean it out. It says, you sure you want to delete this matrix? I'll click OK. Then I want to choose edit. And see, we got the size here. That's how much you can see on the screen. It's not the size of your matrix. As we enter it, it'll resize. So I'll do 1, enter, 1, enter. Now see how it assumes 2 columns? But I can do an up arrow and come over here and right arrow and put in negative 2. And see, it's created another column. I could up arrow and come over here and put our next column, which is 3. Now it'll assume 4 columns as I go through and enter the rest. So I do 4, enter, negative 2, enter, 1, enter, 9, enter, 5, enter, negative 1, enter, 3, enter, 16, enter. Double check my numbers. 3, 9, 16, negative 2, 1, 3, 1, negative 2, negative 1, 1, 4, 5. Okay. As we're working this, keep in mind that we have first row, second row, third row. Okay. Now in general, with the Gaussian Jordan elimination, first step is to get a 1 here. Now I'm going to show this the long way, and then at the end of the video I'm going to show the short way. Actually, let me switch that around. Let me show you the short way to solve this first. I'll press home to get out of that. I'll do my toolbox to bring up the menu here, and I want the math. So if you're over here in app, press math. We want to choose 7 for matrix. I want to choose 3 for RREF. That stands for reduced row echelon form. Now you need to tell it of what. Now we put our matrix in M1, so I'm going to type M1. So I'll do alpha plus or minus for the M, then put 1 in, and then press enter. Now our answers are the far right column, 3, 2, 1. So x is 3, y is 2, and z is 1. Probably the reason why you're watching this video, though, is not to get just the answers, but to figure out how do you show the individual steps. Maybe in your class you're doing it by hand, you want to double check yourself. Just having to kick out the answers maybe isn't what you want. You can do it a lot easier in this calculator. Let me show it real quick. If you press your apps, if you go down to linear solver, you can just type this in and it gives you the answer. So again, the assumption is you're watching this video. Make it to see all the individual steps. Okay, press home. Well, first goal was get a 1 here. We have a 1 there. So let me go down to the next step. With Gaussian Jordan elimination, after we get a 1 in that position, we want to get zeros in the entries right below it. And you have to figure out how to get that. Well, this is row 1, And we ask ourselves for our first entry, what do we multiply by 1 that we then can add to 4 to get that to go to 0? Well, that'd be negative 4. We're going to take negative 4 times row 1, and we'll add that to row 2, and that'll give us our new row 2. Now, for this entry, we ask ourselves, what do we multiply times 1 that we then add to 5 to get a 0 here? And that'd be negative 5. So we take negative 5 times row 1, and we add that to row 3, and that's going to give us our new row 3. Let me do it by hand first, and I'll do it on the calculator and show that. Okay, so we got 1, 1, negative 2, 3. I'm going to take negative 4 times 1 is negative 4 plus 4 gives us 0. Negative 4 times 1 is negative 4 plus a negative 2 gives us negative 6. Negative 4 times negative 2 is 8 plus 1 is 9. Negative 4 times 3 is negative 12 plus 9 is negative 3. And let me double check that. Okay, negative 4, negative 6, 8, 9, negative 12. Okay. Now we'll take negative 5 times row 1 and add it to row 3. So negative 5 times 1 is negative 5 plus 5 is 0. Negative 5 times 1 is negative 5 plus negative 1 is negative 6. Negative 5 times negative 2 is 10 plus 3 is 13. Negative 5 times 3 is negative 15 plus 16 is 1. And I double check myself. I'm not very good at these. I usually make some kind of basic math error when I'm doing it by hand. Okay, that looks good. Well, let's see how to plug this in the calculator. Now for the HP prime, keep in mind that we're going to refer to our rows. So I'm going to take negative 4, and I'm not sure if you actually need times here or not, times M1, that's where we sort our matrix, beginning parentheses 1 to indicate row 1. So we're taking negative 4 times row 1. We're going to add that to row 2. So we're going to do M1, 2. And that's going to give us, I said new row 2, which we're going to put it right back in to row 2. So exact same setup as we have there. Let's do that. Okay. Now I'm going to do negative 4 times M1. So I'm going to do alpha plus minus 1. And then I'll do my parentheses, and I'll put row 1 in there. I'll do a right arrow key to get out of the parentheses, plus. And then I'll do alpha plus or minus for M1, parentheses 2. And now if you're not quite sure if you got it like how you want, you can press enter at this point, and you haven't committed anything, and you see it changes what you're working with to this new row, which looks like our 0, negative 6, 9, negative 3, doesn't it? Okay, well, we didn't actually store it anywhere. So I want to do an up arrow twice to get back to here, and I press enter. And now we want to store it. And store is with the EEX. So I do shift EEX. You should see the little triangle there. And we want to store it back into row 2. So I do alpha plus minus 1, and then parentheses, and then 2. And then press enter. Okay, and you see it. Our row 2 has been replaced. Well, let's write down the next one, and then we'll enter it in. So I'm going to take negative 5 times row 1, so negative 5 times row 1, and add that to row 3, and that's going to give us our new row 3. Okay, so I'm going to do negative 5 times row 1, so do alpha plus minus 1, parentheses 1, right arrow to get out of that, plus alpha plus minus 1, parentheses 3, right arrow. I'll do a store, so do shift EEX, and then I'll put it into M1, 3. Now, it probably is a good idea for you before you store it to actually look at it and see what you're getting. so that if you type something in incorrect here, you just don't destroy your matrix up to that point. I feel pretty confident since I'm writing it out here on this tablet. So let me go ahead and press enter. And now let me check my math since I'm stink at basic math. Okay, 0, -6, 9, -3, 0, -6, 13, 1. Okay, that looks good. Well, our next step in Gaussian elimination is to get a 1 in this position. You work your way down diagonal-wise. So I get 1 here, 1 here, 1 here. And then you work at getting zeros below it. Well, to get a 1 here, I can multiply everything in this row by -1/6. So if I take -1/6 times row 2, that's going to give me my new row 2. Because -1/6 times -6 gives you a +1. Now to write that out in HP prime notation, we'll have -1/6 times M1, and then we put our row in, which is row 2, and this is going to give us our new row 2. And this will be the store, of course, like that. So that's how we're going to enter it in. Okay, so I'm going to do -1 divided by 6, right arrow to get out of the fraction, times, and then alpha for m, and then 1, and then my parentheses, 2, right arrow to get out of the parentheses, and I'll do store, so I'll do shift EEX, and then I'll store that back into row 2. So I'll do alpha plus or minus for the m, 1, then parentheses, then 2, and then press enter. Okay, well, that's coming along. Oh, I didn't do it by hand, did I? Okay. Sorry. Want to show the comparison between two. -1/6 times 0 is 0. -1/6 times -6 is 1. -1/6 times 9 is -9/6, which is -3/2. -1.5. Okay. And then -1/6 times -3 gives us a +3/6, which is a +1/2. And then we got 0, -6, 13, and 1. Now notice I come up with fractions here, but this one has a little bit of an error that's accumulating. That's kind of a concern. We'll see if that affects our final answer. If I press my fraction button at this point, see how it changes those? And it handles the little rounding that's issues coming up, a little numerical calculation problem. I'll press fraction again to put it back to where it was. 2 times actually. The next time put it in mixed number form. Okay, now we got a 1 there. We want to get zeros below it. So I'm going to get 0 right here. Okay, so we're going to take, we think, what do we multiply times this 1 that we then can add to this -6 to get a 0 here? Well, we'll take 6 times row 2, and we'll add that to row 3, and that's going to give us our new row 3. Okay, let me do that step. So we got 1, 1, -2, 3, 0, 1, -3/2, 1/2. Okay, 6 times 0, 0 plus 0, 0. 6 times 1 is 6 plus -6 is 0. 6 times -3/2 is -18/2, which is -9, plus 13 is 4. 6 times 1/2 is 3, plus 1 is 4. Okay, let's use a calculator to see how that works. Oh, let me write out what it would look like in HP prime notation. We're going to take 6 times M1, the second row, plus M1, the third row, and that's going to give us, this is where a store will be, our new row 3. Okay. So I'm going to do 6 times, and then alpha plus minus for the m, 1, parentheses, 2, right arrow to get out of the parentheses, plus, and then alpha plus minus for the m, 1, parentheses, 3, right arrow to get out of that. So 6 times row 2 plus row 3. And I'll do a store, so shift EEX, and I'll store that in M1 3. So I do alpha plus minus 1 parentheses 3, and then I'm going to do enter. Double check everything. Okay, that looks good. That's shaping up. That's what I came up with here, more or less. Okay. Our next goal, we're working our way down, getting diagonals 1, zeros below them. So this is our next one. I want to get a 1 there. So I'm going to take 1/4 times row 3, and this is going to give us our new row 3. HP prime notation, I take 1/4 times M1 3, that's a third row. This equals going to be our store, and that'll give us our new row 3. Okay, so do 1 divided by 4, right arrow to get out of the fraction, times alpha plus minus for the M, 1, 3, right arrow to get out of the parentheses, then store, shift, EEX, and then M1, so alpha plus minus 1, parentheses 3, and then press enter. Okay, looking good. Oops, I didn't do it by hand. So I got 1, 1, negative 2, 3, 0, 1, negative 3/2, 1/2. 1/4 times 0 is 0. 1/4 times 0 is 0. 1/4 times 4 is 1. 1/4 times 4 is 1. Now at this point, this is REF form, row echelon. So that's row echelon form. And we could kick out of this. We could put the x, y, z's and equals back in. And this would look like x plus y minus 2z is equal to 3. And y minus 3/2 z is equal to 1/2. And z is equal to 1. And then after you do that, you would use backward substitution to solve it. Backward substitution means we know what z is. Z is equal to 1. So you take 1 and you put it in for the z here, and then you solve for y. So you take negative 3/2 over, we get 4/2, which gives us 2, so you have y is equal to 2. So you put 1 for z here, and you put y equals 2, and then you solve for x. And then you have your answer. But like I said, I'm not happy with REF on this. I'm going to go the entire way and do REF. Okay. Now after I go down the diagonal like this, I want to go in reverse. I obviously have 1 here. I want to end up with 0 here and 0 here. So we're going like back up the diagonal. Okay, let's see what we need to do. Well, I asked myself, take a look at row 3. What do I multiply times this 1 that then can add to this negative 3/2 that give me a 0 here? Well, that'd be, I guess I'll write it down here. Last row stays as is. And since I wrote that there, we're going to take 3/2 times row 3, and we'll add that to row 2, and that's going to give us our new row 2. Let me just show that. 3/2 times 0 is 0 plus 0 is 0. 3/2 times 0 is 0 plus 1 is 1. 3/2 times 1 is 3/2 plus negative 3/2 is 0. 3/2 times 1 is 3/2 plus 1/2 is 4/2. Or 4/2 is 2. Okay. Let's do that on the HP prime to see what it looks like. So I'm going to write out in HP prime notation here. We got 3/2 times M1 3 for row 3 plus M1 2 for row 2, and that's going to give us M1 2 for our new row 2. Okay, so I'm going to do 3 divided by 2, right arrow to get out of the fraction, times M1, so alpha plus minus 1, parentheses 3, right arrow to get out of parentheses, plus Alpha plus minus 1, and then parentheses 2, right arrow. I'm going to store that in row 2. So alpha plus minus 1, parentheses 2. Helps if I actually put the store in there, though. Let's go back there, and I'm going to do shift EEX. There we go. So always make sure you look at it closely and make sure it matches what you have on paper. And then press enter. 0, 1, 0, 2. 0, 1, 0, 2. That looks good. Okay, we ask what do we multiply times this 1 now that we can then add to this negative 2 to get a 0 here. And that'd be 2. So we're going to take 2 times row 3, and we'll add that to row 1 to give us our new row 1. 2 times 0 is 0, plus 1 is 1. 2 times 0 is 0, plus 1, 1. 2 times 1 is 2, plus negative 2 is 0. And 2 times 1 is 2, plus 3 is 5. The notation for HP prime, this would be 2 times row 3 plus row 1 gives us our new row 1. And equals is our store. Okay, so we take 2 times alpha plus minus 1, parentheses 3, right arrow to get it out, plus alpha plus minus 1, parentheses 1, right arrow, and then store, so I do shift EEX, and then alpha plus minus 1, parentheses 1. Okay, 2 times row 3 plus row 1 gives us our new row 1. Enter. 1105. Okay, looking good. One last thing we need to do. We need to get a 0 here. Well, we're working our way back up. You know, we went from here to here to here, and then we went from here to here and going back the other direction. So this is our pivotal number right here. And you're asking yourself, what times that number that you then can add to this number to get a 0 here? Well, that'd be, let's see, 0, 0, 1, 1, 0, 1, 0, 2. We would take negative 1 times row 2 and add it to row 1. So negative 1 times row 2, and we'll add it to row 1 to give us our new row 1. Okay. Negative 1 times 0 is 0, plus 1 is 1. Negative 1 times 1 is negative 1, plus 1 is 0. Negative 1 times 0 is 0, plus 0 is 0. Negative 1 times 2 is negative 2, plus 5 is 3. Now, HP prime notation, this is negative 1 times row 2 plus row 1 gives us our new row 1. Okay, so negative 1 times and row 1. So I'm going to do, let's see, alpha plus minus 1, parentheses 2, right arrow, plus row 1. So alpha plus minus 1, parentheses 1. Okay, double check that. Okay, it looks good. And then I'm going to store that. So shift EEX, and I'll store that back in matrix 1, row 1. Okay, and you see we get the same matrix as what we have right here. Now, our goal was to get, in this first 3 by 3, that's when we're dealing with 3 equations, 3 variables, diagonal 1, 0, 0 else. And if we did, that's RREF. That stands for Reduced Row Echelon Form. So Reduced Row Echelon Form. And if we have it in that form, then our answers are the far right column. This is X, this is Y, and this is Z. So our answer will be 3, 2, 1. And that's what we saw originally. That's what the REF function did for us. It did all those steps that we just looked at. If you're not required to show the steps on this and you do it in college algebra, I'd recommend just using the function. Why would you want to go through all this pain? But if your instructor wants you to understand the concept of what you're doing exactly, then you can use this in combination with the calculator. And you might be sitting there saying, well, geez, it's pretty simple. Well, yeah, but I have a hard time on these myself. I designed this to come out fairly nice, but if it came out even more hideous, where you had nastier fractions, I would have a hard time myself not making a basic math mistake somewhere. A basic math mistake can cost you lots of money. It's a design error, possibly. So technology is good for helping ensure that you're not screwing up somewhere. Now the calculator HP Prime also has another little feature to it. I don't think it's really worth very much, but I'm going to show this problem again, dealing with it. And actually, I may just allude to it. I may not spend time solving it, using it. Either you're going to use a REF function directly and have it give you the answer, or you're required to show all the steps, and you'll do what I just showed. And then I got 1, 4, 5, 1, -2, 3, -2, 1, 9, -1, 3, 16. Let me talk about the other one, and then you can use it if you want. For example, if I choose this number right here, there's a function that allows you to get zeros above it and below it, so that when you finished, you would see a -2 here, and you'd have a 0 here and 0 here. And then all these numbers would be adjusted accordingly to whatever would give that to you. Very nice feature, seems like. Excuse me. But again, it isn't the natural flow for Gaussian Jordan elimination, and you're either going to use it to get your answer directly, or you're just going to use it to show the flow, and this kind of defeats that purpose. Now let me talk about what the function is. I do my toolbox, choose matrix, and let's see if I remember where it's at. It's this one right here, pivot. So pivot one is the one you want to use. Let me see if I can actually remember how to use this. Let me put my matrix back in there. So I'm going to do Shift 4 to go to my matrix. I'll do Edit to go into this one. And I've destroyed this, but let's see. 1, 1, -2. So 1, inner, 1, inner, -2, inner, 3, inner, 4, inner, -2, inner, 1, inner, 9, inner, 5, inner, -1, inner, 3, and 16. Double check all my numbers. -2, 1, 3, 1, -2, -1, 1, 4, 5. Okay. And then I'll do a home to exit out. Let me do an up arrow and backspace, clean all that out. Okay. Well, to begin with, we got a 1 here, so that's good. But let's get zeros below it. So let's see if I remember how to do this. And toolbox. At first I thought it was pretty neat, and then I realized it kind of defeats what you want to do. So go into matrix. I did 7, and go into basic. Go down to pivot and press enter. So we tell M1. So alpha plus minus 1, and let me do a comma and then 1, and press enter. And obviously I don't remember the syntax for it. Do an enter on that. Do a 1, comma. If this isn't it, then I'll go look it up in the manual. Backspace. Okay, let me go look it up. Book is pretty. The manual is pretty useless when it came to our Gaussian Jordan elimination. Okay, pivot. What's the syntax? Okay, in is given a matrix, a row number, and a column number. Users get to return matrix zeros and column M except for that element in column M. N is kept as a pivot. Okay, so looks like I was close. Close doesn't really count though, does it? Enter. And let me do a comma 1 here. And press enter. Now look what it did. We got our 1 here, we got zeros below it. Okay, now I could store this. So I could up arrow, press enter on that, and I press store. If you don't store it, it's not actually changed anything. So then I'll do a shift EEX and then put it back in the M1. There we go. Now let's work on this second one here. So again, N is our row, and then column M. So this would be second row, second column. Okay, so let me do that again. Toolbox, matrix, basic, pivot, M1, oops, what did I just do there? Try it again. There. Okay, M1, comma, 2, comma 2, enter. Okay, now notice we got zeros above it and zeros below it, but this is not a 1. It's a -6. Well, we could manipulate that if we wanted to, but let me get the last one here, which is the 3, 3. But let me store that off first. So up arrow to that, press enter on it, do shift EX, and then I'll do my, I guess I'm end up showing this to you, aren't I? But that's okay. You didn't have nothing better to do, right? Enter. Gets that. Okay, let's do the last one here, 3, 3. So I'm going to do my toolbox, choose matrix, choose basic, choose pivot, and then alpha plus minus 1, comma, 3, comma, 3. And press enter. Okay, see, we've got zeros there, don't we? Now I worked my way down, didn't I? I started the first one, then the second one, and then the third one. Of course, the problem is I got zeros everywhere else, but I don't got diagonal ones, which is what RREF is about. But that's easy enough because I can multiply this first row, for example, by negative or by 1 over 144. So if I take 1 divided by 144, right arrow, times, and then my M1, parentheses, row 1, right arrow, and store that, shift EX, and then alpha plus minus 1, parentheses 1. Multiply everything in row 1 by 1 over 144. Press enter. That's interesting. I typed it in wrong. 144 times row 1. Oh, I didn't store off the last one, did I? Okay, let me go back up to here. Press enter. And let me do a store on that, see if I can unrecover. Actually, if I just multiply by 1 over 144, then I can reverse it by multiplying by 144. In theory. see if I can really mess it up. Okay, negative 5.99999. Okay, that's questionable. But anyway, what I should have done is I should have sorted off this pivot into M1. Okay, and we want to, okay, the entire pivot stores a matrix, so that's good. Okay, that looks good. Now, let's multiply, go up here, and multiply the entire row by 1 over 144. 0.999999. Okay, that should be 1, but we'll go with that. And then the second row, I'll multiply by 1, divide by 144, times row 2, and right arrow, and that's going to be our new row 2. Once you get going with this, the syntax really does click, except for I didn't do store. Shift EEX, press enter. Okay, that's not looking good. But anyway, in this one, I'll multiply the entire row by negative 1 over 24. So negative 1 divided by 24, right arrow to get out of the fraction, times M1, row 3, right arrow, and then shift EEX, and that's going to give us our new row 3. And press enter. That one came out as 1. These had some rounding issues. Let's see if I press fraction. Pressing fraction one time got rid of that rounding issue. And you see I get same answers. Again, the issue with this is this doesn't demonstrate the natural flow of REF. At first I was excited when I saw it. I thought, well, this is kind of a cool way to do it. But then I thought, no, this is not how it's taught in college algebra. Wouldn't be what they'd be expecting to see on a paper. So the first method I showed you is the best way. If you can think of some kind of way that pivot would help you, then you can use that. Definitely, maybe in a linear algebra class, I could see it in some cases, but it wouldn't be very beneficial for a college algebra class. Anyway, that's doing Gaussian and Jordan elimination on HP prime calculator.